Welcome to Chemistry edition of Darling Fee's channel. My name is X-Coco and I'm excited to present to you how to determine the type of hybridization using simple formula. Please take note of this point. The formula does not work for organic compounds. Do this for me. Kindly subscribe to this channel to see more presentation coming from us. Now let's start. In terms of determination of hybrid orbitals, we have to use the formula to do the calculation. We have what we call the s orbital, the p orbital, and the d orbital. Now when you use the formula and you do the calculation, you have a number to be equal to 2. That indicates that it is sp hybridized. When you do the calculation and you have a number to be equal to 3, that is sp2. Number 4 is also sp3 hybridized. Doing the calculation to get a number 5, that is sp3d. Are you ready? Let's see how we can apply this formula. This is the nice formula that we have. H is equal to, in one bracket, Vc plus capital M minus C, all divided by 2. Please don't forget this formula. It is very, very useful. Now let's see how we can apply the formula or know the terms indicated here, Vc, M, C. Vc stands for the number of valence electrons on the central atom. So for you to be able to do the calculation, you have to determine the central atom. M denotes the number of monovalent atoms. C is the charge on the molecule. So if there is no charge on the molecule, that is equal to 0. The H there represents the type of hybridization. Now, let's start with an example. But before we do that, we have to know this term, monovalent. That is an atom with a valency of 1. What are some of the examples we can talk about? We have hydrogen, lithium, sodium, chlorine, fluorine, etc. The reason being that they have a valency of 1. Now let's start with this simple formula. H is equal to Vc plus capital M minus C all over 2. In the first example, Cl2, the question is, what is the central atom? The central atom in our case here is Be with atomic number 4. So when we write the configuration, that will give us 2, 2, which determines the number of valence electrons that we can get. So over here, the valence electrons are 2. So keep that in mind. Let's move to chlorine. The question is chlorine a monovalent atom? Yes, of course it is, because it has a valency of 1. And there is a number attached to chlorine. We'll be using that number. Do we have any charge on the molecule? There is no charge, which indicates that the charge here is 0. Now let's see how we can put the figures in the formula. Be gave us valence electrons of 2. So that is what we have over here. Now we have a number here which is attached to chlorine atom, which is 2 times 1 because chlorine is monovalent, minus the charge. There is no charge on this molecule, which is equal to 0, all divided by 2. So that gave us 4 over 2 is equal to 2. And as I said, when you have H to be equal to 2, then that indicates that it is sp hybridized. So that is for the first example. I hope you enjoyed this. Let's move to the second one. Example 2. We have Bf3. B here stands for boron. Boron has atomic number 5. configuration is 2, 3. So the number of valence electrons in this will be 3 as indicated in the equation. F is also monovalent with a valency of 1. But the number attached to F is 3. And that is 3 times the 1. Do we have any charge on this molecule? That is charge on this molecule. That is no. So that is 0 as indicated. All over 2. That gave us 6 over 2 is equal to 3, which indicates that it is sp2 hybridized. Now let's see. Example 3. This is CO2 molecule. The central atom here is carbon. So we need to know the valence electrons for carbon. Writing the configuration, that will give us 2, 4. That is with atomic number of 6. Valence electrons here is equal to 4, and that is what is inserted over here. Is oxygen a monovalent atom? No. So that is 0. Do we have any charge on this molecule? No. That is also 0. So that will give us 4 plus 0 minus 0, all divided by 2. And that will give us 4 over 2. 2 indicates that it is sp hybridized. Now let's enjoy ourselves. Let's move to the 4th example. This time around, we have a charge on it. Let's see how we can use this simple formula to solve and get the type of hybridization. C here is having 4 valence electrons. Oxygen is not a monovalent atom, so that is 0. Minus the charge. Yes, we do have a charge here, which is 2 minus. So we have to insert that in the formula, as we can see over here, all divided by 2. So H is equal to 6 over 2 is equal to 3, which indicates that we have sp2 for the molecule here. Let's see for the 5th example. In this example, which is ammonium ion, we have a charge of +1. Let's see how this simple formula can help us. H is equal to 5. How did we get a 5? The central atom is nitrogen. Atomic number is 7. So when you write the configuration, that will give you 2, 5. So that indicates that the number of valence electrons is equal to 5. Let's move to hydrogen. Is it a monovalent atom? Yes, it is, with a valency of 1. But there is 4 attached to hydrogen. So 4 times 1 minus the charge, which is indicated in this molecule, all divided by 2. So H is equal to 8 over 2, which is equal to 4. And that also indicates that it is sp3, as we saw in the previous slide. Let's take the next example. That is the last one. This is a water molecule. The central atom here is not hydrogen, but rather oxygen. Oxygen here has atomic number 8. So in writing the configuration, that will give us 2, 6, meaning that the number of valence electrons is 6. Is hydrogen here monovalent? Yes, it is. So that is 2 times 1, and that is what is indicated here. We don't have any charge on this molecule, so that will give us 0, or divided by 2. And that gave us 8